Op amp is nothing but is the one which is having high gain, high input impedance, low output impedance, and voltage amplitude enhancement. So operational amplifier is basically consist of multiple differential amplifier which is having high gain, and basically it has two inputs and one output. So this is about operational amplifier. Next, we need to understand the working of differential amplifier. The name itself says the input applied is two input, where the difference between two input is applied as input to the device. So to understand the working of differential amplifier and the characteristics of the differential amplifier, we need to understand two perspectives. That is, for the op amp, when we apply single input and take single output, and similarly for the op amp when two inputs is applied and two outputs is taken. So let's analyze all this condition. The first condition is single-ended operation. If you can observe in single-ended operation, the input is applied to the positive terminal, or else we can call this as non-inverting terminal. When the input is applied to the non-inverting terminal and inverting terminal is the grounded, output obtained is amplified, but output is in phase with respect to input. Similarly, when the input is applied to the inverting terminal and the non-inverting terminal is grounded, output obtained is in 180 degree out of phase with respect to whatever the input which is being applied. So basically the single-ended operation says that input can be applied to any one terminal, whereas the other terminal has to be grounded. If the input is applied to the positive terminal or non-inverting terminal, output is amplified, but it is not inverse. The polarity remains same. But whereas in the case if the input is applied to the inverting terminal, output obtained is amplified, but it is in 180 degree phase shift with respect to input. But output can be taken from only one terminal. Now let's understand double-ended input, but output is only taken from one terminal. Let's analyze this. If we can observe here, the input is applied to both the terminals. Input is applied to both the terminals. So the input applied is nothing but difference between both the input, that is VD. And here, whatever the output is obtained it is in phase, but it depends on the difference of input. So polarity remains same, but output voltage depends upon the differential input whatever has been applied. If the input is applied with respect to two different terminal, but here it is applied common. In common it is applied, but whereas here the input applied is to different terminal, output is in phase, but it is amplified, same as this condition. Next comes the condition double-ended output. So input applied is also to both the terminals, output is also taken from both the terminals, that is V01 and V02, where output is taken from both output terminals. So let's understand first this case. In this case, both the terminal input is applied, but output is also taken from both the terminal. In this case, for the non-inverting terminal, output is applied, whereas the inverting terminal, it is grounded, but still output is taken across both the condition or both the terminal. Let's see what happens. In this case, whatever the output obtained will be twice as large as input. So let's check that how it is going to happen. The name itself says the differential output means output will be equal to the difference between two output. Let's assume that V in is equals to 10 volt. If V in is equals to 10 volt, since this input is to the non-inverting terminal, V01 will be equal to 10. And let's assume, because of virtual ground, where the concept I'll be explaining later, V02 will be minus 10. Therefore, this will be equal to 10 minus of minus 10 will become plus 10. So 20 volts is the output. So it clearly says the output is twice as input. So next comes this condition. Here input is applied to the non-inverting terminal and inverting terminal is just grounded, And instead of taking the differential input, if the output is taken individually from the both the terminal, what happens? The output with respect to non-inverting terminal, output is amplified but polarity remains same. But whereas in the case across this terminal, output magnitude remains same but polarity is inverse. So the difference between this and this is whatever the output obtained across two different terminals, polarity just changes, that is inverse will happen, but magnitude remains same. But here the differential output will be twice the magnitude of input voltage. And just to compare with respect to single-ended input and differential input, here in this case input is applied to only one terminal, output is taken across one terminal. But whereas in the case of double-ended, usually noise gets cancelled. The noise gets cancelled because the input applied is difference between two input. Since the differential input voltage is applied to the device, whatever the signal we are obtaining, the strength will be maximum in this case compared to single-ended operation. At the same time, the noise can also be cancelled to the maximum extent in the case of double-ended operation. So now since we know very well how the double-ended input, double-ended output will work, how the single-ended operation will happen, in upcoming class, we can understand very clearly about differential amplifiers. Okay, I'll stop here.